Everyone, I'm back with a new project about element name in Abacus. Before starting this tutorial, please subscribe my channel and liking the video to support us. We put a lot of time and effort into creating content for you, and your support means a lot. Thank you so much. Choosing the right element type is critical in final element analysis. If you have used Abacus, you know what is a C3D8R element. This is the most widely used final element for solids. But do you know exactly what is represents? Why does it have the name? As you know, in Abacus, the elements name are very smart. They are self-explanatory, and I love this kind of name. And also maybe you. It gives you a clear idea of the element's main features just from its name. Let's break it down. Like this kind of element name C3D8R. The first letter represents the element type. I mean, in this case, C means continuum element, a cast solid for mechanical analysis. We also have S, like this name, S for shells, or COH for cohesive elements among theirs. The second group of character is the dimensionality 3D for this one. So this is the first letter, first case, and this one is the second one. For example, 3D. And 3D is related to example which is related to, for example, a 3D model. And some other type are AX. AX like this one. It means related to axisymmetric element, and PE for PE mention for plane strain. PE like this one. PE plane strain, or PS for plane stress, and more. The next character is the number of nodes, like this one, 8, represent the number of nodes. As a linear hexahedron, our element has 8 nodes. You can see in here 1, 2, 3, 4, 5, 6, 7, 8. So we need to mention 8 in this element type. And two are typically linear beam, like this one too. Mention the linear beams. Truss, like for truss like T3D2, or connectors. And three for linear 2D triangles or shell elements, like S3, like this one, S3. And four mention about cohesive element in 2D, COH 2D4, or linear tetra, C3D4. Another one is 6. 6 is related to related to wedge or quadratic tree. CPS, for example, CPS 6. Or another one is 8. 8 for hex or quadratic awkward, like CPE8. CPE8. And another one is 10. 10 for quadratic tests, C3D10 is for example like this one C3D10, like hybrid sorry, like this one 10, and another one is 20 for quadratic hexa and etc. um, Again, please subscribe my channel if you enjoy this kind of video, and liking the video to support us. We put a lot of time and effort into creating content for you, as you know, and your support means a lot for us. You don't miss anything, just support us and increase our motivation. Thank you so much for your support, and subscribe my channel and also like my video. The last character, like this one, the last character are optional and represent additional features. The most common one are R, means for reduced integration. For this kind, for example, C38R, when we use R as the last character of this element's name, means reduce integration point. Or I means incompatible mode, like this kind of element incompatible. I means incompatible modes, and T for coupled temperature, when you use temperature simulation and use T means a coupled temperature. uh, I find this naming rules very handy and intuitive for a final element method. And if we need anything else like node labeling, integration point, and so on, the Abacus documentation is the place to go. And Abacus documentation, as you know, is one of the professional document for user to learn about behind a simulation. So I suggest you to search and find Abacus documentation, and then study the content of that documentation and get lots of information about simulation. Thank you for watching our video, especially this video. If you enjoy my channel and my video, please consider subscribing to our channel and liking the video to support us. We put a lot of time and effort into creating content for you, and your support means a lot and increase my motivation and also my group motivation to prepare lots of practical video for you. Thank you, good luck, bye.